We have defined spontaneity. Now we need to understand why some processes are spontaneous while others are not. One could be tempted to state that spontaneity is associated with a decrease in energy or enthalpy. Indeed, when one falls or jumps from an airplane, one loses potential energy. However, during the fall, the kinetic energy increases as one potential energy decreases. Upon impact with the ground, the kinetic energy has vanished and the potential energy is at a minimum. So falling is a spontaneous process and is accompanied by a decrease in energy of the system. Now, we need to ask whether energy is always decreasing during spontaneous processes. Let us look at the fate of an ice cube, or rather an ice heart, left on your kitchen table. Obviously, unless the temperature of your kitchen is below 32 degrees Fahrenheit, the ice will melt spontaneously. We learned in chapter 1 that melting or fusion, that is the transformation of a crystal phase into a liquid phase, is an endothermic process. In other words, the change in enthalpy and in energy of water molecules are positive during melting. So the enthalpy and the energy of water molecules increase during melting. During the process of mixing a solute, here a dye, with a solvent, the changes in energy or enthalpy can be negative, non-existent, or positive, depending on the chemical composition and structure of the solvent and solute molecules. More will be said about properties of mixtures in the next chapter. The phenomena of transpiration and evaporations are both endothermic. Hence, again, water molecules increase in energy and enthalpy as they change phase between the liquid state and the vapor state. This photo shows different stages of the crystallization process for a synthetic polymer. Since crystallization is an exothermic process, the energy and enthalpy of molecules decreases as a result of their more ordered and compact packing in the crystal state than in the liquid state. Iron, when it gets oxidized during rust formation, lowers its energy and enthalpy as it becomes bound to oxygen atoms. Combustion reactions are exothermic. Hence, the carbon and hydrogen atoms present in hydrocarbons lower their energy and enthalpy as they become bound to oxygen atoms in carbon dioxide and water respectively. On the preceding slide, we saw examples of spontaneous processes for which changes in energy and enthalpy were zero, negative, or positive. The energy and enthalpy remains constant during the isothermal expansion of an ideal gas and during the mixing of ideal gases. We also saw evidence that H and U decrease during exothermic phase transformations, such as crystallization, condensation, and vapor deposition, during cooling, and during combustion reaction. Finally, the enthalpy and the energy were shown to increase for phase changes such as melting, vaporization, and sublimation, for the heating of substances, and for the dissolution of certain salts in water. Hence, focusing only on the changes in the energy or the enthalpy of a system is not going to provide us with an explanation for the meaning of spontaneity, since spontaneous processes can be characterized by positive, zero, or negative delta H and delta U. While some may have been tempted to think that systems evolve spontaneously in the direction that minimizes their energy or enthalpy, others have suggested that systems evolve spontaneously in the direction that maximizes their disorder. Certainly, on the human scale, there are many examples of increasing disorder in systems that are left unattended. I know that my desk becomes spontaneously messier unless I work to clean it up. A nicely organized pile of leaves will spontaneously get scattered under the action of the wind, the reverse process being unfortunately very rare. The same argument applies to the cleanliness of a floor over time. There are many examples of spontaneous molecular level processes that are also accompanied by an increase in the disorder of a system. For example, the mixing of gases, the dissolution of a solute in a solvent, and the endothermic phase transformation such as melting, vaporization, sublimation, and even protein denaturation, to name a few, are processes which can occur spontaneously under the right conditions and are characterized by an increase in disorder. A liquid is indeed more disordered than a solid. A vapor is much more disordered than a liquid. A protein has much more conformational disorder in the denatured state than in the native state, and so on. However, there are equal numbers of molecular level processes that are spontaneous and exhibit an increase in order. For example, crystallization, condensation, and vapor deposition are examples of exothermic phase transitions which lead to an increase in the order of the system and can, under the proper condition, be spontaneous. Binding and complexation are other examples of processes with similar characteristics. So, focusing only on the change in the level of disorder of the system will not allow us to account for the spontaneity of a process. Indeed, the examples considered above indicate that spontaneous processes can lead to an increase or a decrease in the disorder of the system.